In astronomy, everything we know about the universe, we know because of light. Isn't that wild? Other sciences have it too easy. A biologist can poke a cell, a chemist can mix stuff and see what happens. But in astronomy, aside from nearby objects like the moon, we can't touch or sample anything. We rely on light, and only light, to understand the cosmos. And for my PhD, I'm making it even harder. I'm studying how galaxies evolve using ultraviolet light, light that our eyes can't even see. But what can this invisible light possibly tell us? Well, to understand that, we have to start with the building blocks of galaxies, stars. Those twinkling dots in the night sky are giant balls of plasma, constantly emitting light. As light travels from their hot cores through cooler outer layers, it carries valuable clues about their physical properties. That's how astronomers figured out that stars aren't random. They follow well-defined patterns. Take our sun. It's yellow because it's relatively cool for a star. That also means it's small, dim, and long-lived. Bigger stars, though, are hotter, brighter, and interestingly bluer. But here's the catch. Those hot blue stars burn their fuel so fast that they die young. Think of them as the rock stars of space. Brilliant, intense, but short-lived. In contrast, smaller red stars are more low-key. They burn slowly and live for billions of years. So what does this have to do with galaxies? Well, when we look at a galaxy's color, it can tell what kind of stars it has. A blue galaxy, that means those young, short-lived stars are still around. So it's likely still forming stars. But if a galaxy has redder colors, it likely means that blue stars have died off and no new ones are being born. These are the so-called red and dead galaxies, galaxies that seem to have shut down star formation. But here's where things get interesting. Stars emit light across the entire electromagnetic spectrum, including wavelengths our eyes can't detect, like the ultraviolet. In that part of the spectrum, hot young stars stand out even more. And that's where my research comes in. What if these so-called dead galaxies aren't actually fully dead? They might still be forming stars, but at such low levels that we miss it in the visible light completely. It's like discovering a faint heartbeat in someone we thought was long gone, an astronomical resurrection. If true, this would reshape how we understand galaxy evolution, meaning we would need to rethink and rewrite key pieces of our physical models. In the end, it all comes back to this. The way we look at the universe changes how we understand it. And by shifting our perspective, we can uncover a more complete picture of reality itself. That's the beauty of astrophysics. With just light, we can trace the history of the cosmos.